electric and magnetic field in crossed configuration. Electric and magnetic field in crossed configuration. Okay. In atomic physics, quite often it becomes necessary to select only those particles, electron, proton, etc., that have the same velocity, and out of a bunch of particles having a wide range of velocities. Okay, this is the basis of a velocity selector or velocity filter, and achieved by using the electric and magnetic field in crossed configuration. When uniform electric and magnetic fields act perpendicular simultaneously over the same region, the fields are said to be in cross configuration. Okay, when electrons pass through such a region, they are deflected simultaneously by both the fields. Okay, two metal plates are separated by a small distance. Okay, two metal plates separated by a small distance. When charge set up a uniform electric field E in the y direction. E in the y direction. Okay, E in the y direction, and a uniform magnetic field B is also set up in the same region between the plates in Z direction. Okay, plates in Z direction. Okay, let the magnetic field B is acting into the page. Both these fields are mutually perpendicular and also perpendicular to the direction of motion of electron. Direction of motion of electron, x direction. Let the stream of the electrons enters the region of crossed configuration. Regions of crossed configuration with a velocity v. With a velocity v. Okay. The electric field E deflects the electron upward with a force. The electric field E deflects the electron upward with a force, upward with a force, F E equal to E capital E. This is equation number first. And magnetic field be deflected then downwards with a force, and magnetic field B deflects them downward with a force, with a force FB equal to EVB. Okay. If the magnetic of these two fields are adjusted such that the force acting on the electrons are equal, so that the electron will not experience any net force under this condition. If the magnitude of these two fields are adjusted such that the force acting on the elements are equal. Okay, the force acting on the elements, if the force acting on the elements are electrons, are equal, so that the electrons will not experience any net force under the condition. So E capital E equal to EVB, then V equal to E by B. Okay, this is the equation number second. Okay, the electrons experience a zero net force as the above two forces are equal and opposite, thereby balance each other. Okay, therefore they will not deviate from their original straight line path x-axis and travel without any change in their velocity v. By knowing the value of electric field and magnetic field, the velocity of electrons and hence their kinetic energy can be determined. In 1897, J.J. Thomson using this method for the determination of electron beam velocity. Okay, next heading, velocity selector. Velocity selector. Okay, velocity selector. Velocity selector. Velocity selector. Velocity selector. Velocity selector, also known as velocity filter, is an electro-optic device. Okay, velocity selector, also known as velocity filter. Okay, velocity selector. Velocity selector. Velocity selector, also known as velocity selector, also known as velocity filter. Velocity filter. Velocity filter is an electro-optic device. Is an electro-optic device. Is an electro-optic device which uses the combined effect of two mutual perpendicular fields. Two mutual perpendicular field. Okay, which use two mutual perpendicular field E and B acting simultaneously. E and B acting simultaneously over the same region. Okay, over the same region. Velocity selector, also known as velocity filter, is an electro-optic device which uses the combined effect of two mutual perpendicular fields E and B acting simultaneously over the same region. The crushed configuration of E and B select a stream of charged particles of single velocity from a beam of charged particles having a wide range of velocities. Okay, this crushed configuration of E and B, this crushed configuration of E and B select a stream of charged particles. Select a stream of charged particles of single velocity from velocity from a beam of charged particles, a beam of charged particles, a beam of charged particles having a wide range of velocities, having a wide range of velocities, okay. Velocity selector, also known as velocity filter, is an electro-optic device which uses the combined effect of two mutual perpendicular fields E and V acting simultaneously over the same region. This cross configuration of electric field and magnetic field select a stream of charged particles of the single velocities from a beam of charged particles having a wide range of velocities. Okay. Here the electric field E is produced in a vertically downward direction y-axis. Here the electric field E is produced in a vertically downward direction y-axis, downward direction minus y-axis by a set of charged particles plates, and a uniform magnetic field B is applied perpendicular to it. Okay. Acting into the paper, if the two fields E and V are adjusted such the electric field force balance the magnetic field force B acting on the electrons moving with velocities v plus delta V, then these electrons are not deflected and continue to travel along the straight line, having velocity V. Subsequently, they pass through the slit at P. Okay, slit at P. Those electrons moving with velocity lesser than V dash is less than V, will get deflected upward along OQ, and those moving with a greater velocity than V dash is the greater than V, will get deflected downward along QR. Thus a strictly homogeneous simple velocity electron beam traveling along OP. Traveling along OP. Okay. Traveling along OP is obtained. This arrangement is therefore known as velocity selector or a velocity filter. This form an essential components in band bridge mass spectrograph. Okay, this form an essential component in band bridge mass spectrograph. Okay, next heading, cyclotron. What is cyclotron and how to work, and many types of information about the cyclotron in next heading. Okay, thanking you. Sulfur atom in second excited state. Sulfur